Hello, my name is Erik, and I will be giving this talk. The name of the talk is Coding with Dinosaurs. Why? Just because my son loves dinosaurs. But we will be having a conversation about functional programming patterns that personally I feel that they are really useful in some contexts. And I would like to thank our sponsors for making this conference possible. And then I would like to set some expectations about this talk. First, we are not here to blame other people's code. I would like to have a debate, and I would like to have a conversation around these functional programming patterns. That doesn't mean that other programming style, like object-oriented or whatever you do, or the programming language that you use in your daily work, that doesn't mean that functional programming is better or is the best. This is not the intention of the talk. Also, I would like to be clear that we are not doing this talk because functional programming is something that is trendy or whatever. No, this is not the intention. The intention is to share some tips about these functional programming patterns with all of you. And also, I would like to be really far from trivial details. We are not going to have a conversation here about correct programs or stuff like that. I would like to have a conversation about useful programs. Okay? So, let's start with the story. Okay? So, about 2 years ago, when I joined Liveful Connect, I had a conversation with Jose Carlos, the CTO. Jose Carlos, right? Okay. And during this conversation, he mentioned that we have a challenge, which is we have a huge monolith that mix both functional technical abstractions, like starting, creating data pipelines, monitoring these data pipelines, and inside the same monorepo, inside the same monolith, we also have abstraction for the business. So we have all these details about what a country means for Liveful Connect, what a vertical means for Liveful Connect. And all these concepts are mixed together with these abstractions, these technical abstractions. So he offered me this challenge. I was young, I was stupid, and I said yes. And then after some time, I realized that I don't have all the skills to tackle this challenge. So I called Jordi Pradel, who works for Agilogy. He's a small company. And I offered him to help me with this challenge. He was young, you know the rest. So he joined the team together with Victor Douet and with Danny. And then we have Gaston, we have Adela at that moment, we have also David Martinez, we have Carlos. And as a team, we come out with a strategy. And our strategy was, at that moment, the hypothesis that combining functional programming with domain-driven designs could be a good way to put some order to the chaos that we have in this monolith. So I would like to start by showing this piece of code. It's writing in Java. It's a simple function. The only thing that you do is you take a password as a parameter and a hash as a parameter. And then you compare the password with the hash, and you make a decision, an authorization decision. Is the password matching the hash? In this case, you answer yes. If not, you answer true or false. Okay? What is wrong with this code? What is wrong with this code? Well, there is nothing wrong with this code. It's a code that could be perfectly working 20 years ago, and probably there will be a lot of lines very similar to this in your current code bases today. So The thing is that if you're part of the team and someone open a pull request with this code, probably this person will have a lot of comments about, oh, code smell, legacy, design pattern, domain-driven design. You know, all this kind of conversation that we like to have in the pull request. So let me try to explain a bit some of the problems or some of the improvement that we can do to this code. First, the first thing that comes to my mind is the primitive succession code smell. The code smell were first invented by Ken Beck, but they become mainstream by a book by Martin Fowler, as anything else in the software industry. And in this case, this code smell mentioned that special strings like the password and the hash, they should be refactored to replace this data value with an object. There is another thing that comes later, which is object calisthenic. The object calisthenic they are exercises, and they propose a set of rules, and then you need to code following these rules. The object calisthenic, the rule number 3, states exactly the same as the code smell. So you need to wrap all primitive and string within objects. So it's almost the same. If we took both the code smell and the object calisthenic rule, we will end with some code like this. We will replace our password with the password object, and we will replace our password hash with a password hash object. In Java, this is a possible implementation in Java. Okay? So the thing is that at least in Java, we have different abstractions or we have different types for abstraction and for performance. On one hand, we have classes, and we used to use our classes to organize our code and to have better abstractions. But on the other hand, we have primitive, like integer, like Boolean, and this kind of stuff, that they are designed to be performant at runtime. And you need to choose between abstraction or performance. So this is a problem that we cannot solve by only applying the code smell or the object calisthenic rule. Okay? So let's move on. Let's see if we can find something better. We have connaissance. Connaissance is a software quality metric. In this case, the connaissance that is interesting for this case is the connaissance of position. The problem is that when you are coding, you need to keep a lot of things on your mind. Okay? And in this case, you need to keep in your mind the order of the password parameter and the hash parameter. Imagine that you are calling this function with the password and with the hash. You need to be really sure that the password comes before the hash, because otherwise you will be creating a problem in production. Okay? If you switch the places. So the connaissance of position, they mentioned that you need to refactor to introduce named parameter here. Who in this room knows what named parameter is? Very few persons. Do you know why? Because not all language has built-in support for naming parameters. So the intention is very good, but it's not practical. What is naming parameter? I'm switching to Scala because it's one of the programming languages that they have built-in support for naming parameters. For the rest of the presentation, I will be showing a sample of code written in Scala, mainly because this is today the programming language that I'm using in my current team, in my current position. So I'm more comfortable showing this information in Scala, having this conversation with Scala. But this doesn't mean that the patterns that we will discuss today they can be used in other programming languages. Okay, so Scala here is accidental. Okay, so what is, by the way, The syntax is pretty much the same like in Scala, like in Java, sorry. You will see that in front of the definition of the method, there is the word def, and then we are switching places between the type and the name of the parameter. And the same thing happens with the type of the method, okay? Cool. So the thing is that named parameters, they become really useful at the moment that you want to use the validate hash function. In this case, you are putting the name of the parameter in front of the value. And in this way, you don't need to remember what comes first, the password or the hash. You can replace it, you can put them in any order, and the compiler will do this for you, okay? So this is naming parameters. So finally, another thing that comes to my mind is that from the point of view of the clean code, we are using meaningful names. So from the point of view of clean code, this code is perfect because we don't need to express anything additional in comments or because just reading the method definition, you have an idea of what is happening, okay? So the thing is that from the point of view of clean code, everything is perfect here. First thing, names and not case safety. Okay, let's see. Now imagine that I would like to introduce the first functional programming pattern here. Instead of using all this information that we have in CodeSmell, in Connaissance, in Object Calisthenics, and clean code and everything, I would like to use something that is really, really, really natural for us. Types. Imagine that you have in your programming language a type for numbers, integers. You have a type for booleans. You have a type for every time that you need to use a piece of information that has only one field, probably there will be a type in your programming language that offers you, that gives you this built-in support, okay? So the thing is that we can do the same with every time that we need to define a concept, like a password in this case, we can do it by defining a password type. The thing is that this pattern, the new type pattern, was first introduced in Haskell. And there is no built-in support for new types in Scala, but you can use new type by means of a library. So in this case, we are just defining this type by means of this library. At the end of the day, the code is exactly the same. So let's see why this is different to a class. So the first thing is that you will have different data types at compile time. So you have abstraction, but on runtime, you will not have to pay the additional memory or the additional computation because the compiler will do this for you. It will, even when you are using the type in your code, the compiler will unwrap these types into primitive. So in runtime, you will be using primitive. In runtime, you will have the performance, and in your code, you will have the abstraction. Okay? So this is the main difference. However, of course, there is no free lunch. That means that compiling a Scala code, when you use this library, is painfully slow. It's painfully slow. Because, of course, you are putting additional effort in the compiler, because the compiler needs to do this unwrapping and needs to replace all this type with the primitive form. Okay? So this is something that you need to take into consideration, but there is an enhancement. This proposal from the Java virtual machine, this proposal, they are evaluating this, which is a huge change in the way in which the Java virtual machine works, because if this proposal is finally accepted, then we will have the possibility of creating new types with the built-in support of the Java virtual machine. So for me, this is something that it will be really useful. So when was the last time that you used a Boolean in production and the value was not true, was not false? When was the last time that this happened to you? Never, right? Because the types are safe. You cannot have a Boolean with other values than true or false. We are going to do exactly the same with our types. So in our password and in our password hash, we will do this validation during the creation of the type. Okay? So this is our second pattern for functional programming. What we are going to do here is to introduce the third pattern, which is the smart constructor. We are going to use the smart constructor to create this password and this password hash that they always has correct values. How? Well, the thing is that the only way in which you can create the password is from a string. So you will have only one constructor from string. And every time that in your code you need to create a password, you will use this smart constructor. Inside the smart constructor, we have the validation. If you come from Java, like me, this is going to sound a bit dangerous because in Java, validation is an exception. In the case that there is a business rule, like in this case, the password cannot be empty. This means for a Java developer that we need to fail with an exception. Oh, validation exception, and that means that we will have a constructor that will raise an exception, will throw an exception. Okay. The thing is that we need to find a way in which we will not doing this. We need to find a way to avoid throwing an exception when the type is not correct. There are many options here, and one of them is to use the either monad. I'm sorry, at the beginning of the presentation, you see that I put this small message that this is not about monads or not. The thing is that what is either in this case? Either is very easy. Is a type that it can be right or left. Okay, sorry, or left or right. In the left, you will have the value of the computations that are invalid, and in the right, you will have the value of the computation that are valid. So let's see how we can use this. How can we use this? This idea is an idea from this person, Scott Waldstream. He mentioned that one way in which you can create programs is by composing your functions. So either as any other monad, at the end of the day, what is given to you is a way to compose functions. And this way have like two different channels. The green channel, he made this, he used railway in this case because it's the way in which he tried to explain this concept, okay? So the green channel is the right channel. Imagine that you validate the password and the password is okay. It doesn't contain, it contains some information. It's not a blank password. So the business rule is okay. So in this case, the output of this validation, you will connect the output of this validation with the input of the next function that you will execute. So monads, at the end of the day, what gives you is this composition, okay? And then you will have the second channel, that is the error channel. You handling the error in this kind of composition is about bypassing every function that you have, that you compose using a monad. They simply, in the moment that an error occurs, you will bypass this value to the next one, to the next one, to the next one, and to the next one. And in this way, the monad gives you two channels, one channel for success and the other channel for error handling. That's all. But now imagine that you are building a railway across Europe. Of course, you will be able of connecting a railway from Spain with a railway in France, because we use exactly the same standards. Across the European Union, probably it is easy to connect a railway from France with the railway of Spain. Okay. Now imagine that you have to connect a railway with China or with Russia or with other country that they use a different standard. This is not possible because the railway will be wider, narrow. You will find this kind of problem. The same thing happens with monads. You can only compose functions using the same monad. So before starting your composition, you need to choose your monad. Okay. So now let's try to understand to introduce the next pattern. Now we have the password. Now this password is a type. We know that there is a smart constructor that avoids having incorrect password in runtime. This is not going to happen in the same way that it never is going to happen that you have a Boolean with a value which is different from true or false. But the thing is that the password and the password hash, they contain exactly the same information. The only difference is in the format. The password is in clear text, and the password hash is you apply a hash function, so you will have exactly the same information, and the only difference is in the format. So there is another pattern from functional programming, which is the phantom type parameters. That is quite easy. At the end of the day, what you are doing here, you are introducing a generic. If you come from Java, this is a generic. If you come from Scala, this is a type parameter. But the only thing is that this type parameter, this generic, it will not change the behavior. It will not contain any additional information. We are used to use generic, for example, with list. List is a kind of container, and inside a list you can put a string or you can put integer or whatever, right? This is not the case. The case here is that you are using this generic just to have different type for the password in clear text form and the password in the hash form. Okay? Okay? So let's move to the next, and this is going to be our final pattern. We put a lot of effort here in the parameters. We create this parameter using new type, we apply the smart constructor, we apply the phantom type parameter, and the same thing happened with the hash. And then we end up by returning a Boolean. So we have a lot of abstraction, we have a lot of effort in the definition of the parameter, but the function is simply dump this information and it will return a Boolean. Okay? This is what we call Boolean blindness. Okay? Boolean blindness is when your function is just dropping information that is useful, it has value for the next step, because at the end of the day you are doing here an authorization decision, and then you are operating on that Boolean instead of operating on a different type. Okay? So the problem here was that I started the talk by showing you a tiny piece of code, and I asked your opinion about a tiny piece of code, the validate hash function. The problem is that you have no context to understand what is this function, what is the problem that this function is solving. Okay? So let's step back. And at some place, there will be a user story defining exactly what is the business need that we are trying to solve here. In this case, there is a user who wants to access a system that is protected behind some access mechanisms, and the user wants to do things with this system. Okay, if we start from here, probably we will have a different way or to attack this problem. In the right hand, you can see the solution that I proposed at the beginning of the talk with all the improvements. And on the left side, you can see the new solution. The new solution is based on the final pattern, the evidence pattern. If you have to pick one thing from this talk, please read this post by Alexis King. She was thinking in this problem, and then she realized that a program can be modeled, can be seen as a flow of data. And the thing is that with every step that you take in this flow, you will get more information, and you will know more details about the problem that you are trying to solve. So in this case, you start with the username. Okay, this user, the user who is trying to access the system, is identified by the username, and then the user, he will provide you the password in clear test. Okay, and you will run your validation function, and you will return an access decision. It's not a Boolean anymore. It is an access decision. Let's see what is inside the access decision. In the access decision, you are keeping some information from your context that is important, that has value for the next step. What is the information that has value for the next step? The username, because the username identifies the user. So instead of returning a Boolean, you will be returning this new data structure that will keep the information that is useful. And then you will add additional information. What is the additional information here? Well, you will be returning the access decision. You will say, okay, this user identified with this username is granted or is forbidden. And this is how this pattern works. Okay? At the same time, you will be dropping some information which is not useful. What is the information that is missing here? The password in clear test. You don't need to provide the password in clear test, because at the moment that you make the access decision, the user is granted. At this moment, you will not need this password in your flow. This information is useful. So with every step that you take in this flow, you have the possibility of propagating the information that has value for the next steps in the flow. You have the possibility of creating new information, and you have the possibility of dropping information which is not useful. Okay? And this is the evidence pattern. So finally, let's see a possible implementation of this validation function. There is a lot of scalar rock and roll here, so just forget about all this rock and roll. There is one thing that I would like to mention, is that we are using generics in the signature of the method, because this is the way that we will use to inject the monad. Do you remember that we cannot use different monads? We cannot combine functions with different monads. So a good thing for me it is that in functional programming, there are a lot of patterns coming from object orientation and from other programming styles that you can still use. You can see in the implementation that we are injecting a vault. A vault is just a repository for password in clear test. You will ask the vault, you will say, oh, do we know the password of the user? And you will pass the username, and it will return you the password hash that we have registered for this user in our system. This is simply injection. This is dependency injection, like in Solid. So this is nothing new. But at the same time, we are also injecting a technical abstraction in the type parameter. The f that we injecting in the type parameter is just a monad, but the monad has nothing to do with the business. So everything that we need that has nothing to do with the business, we have a second dependency injection, which is in the type parameter. So let's focus on this part. This is the implementation. Here you can see that we are starting with this for. This is a for comprehension that has nothing to do with the for loop. What is a for comprehension? It's syntax sugar, something that you don't need to know. The thing is that composing a function by means of a monad means that every time that you want to compose a function, you have to call a flat map or a map. This is boilerplate. So a for comprehension is just a syntax sugar to reduce this boilerplate. Every time that you see this single left arrow, this is a flat map, this is a flat map, and every time you see a yield, this is a map. That's all. So we will start by calling the hash function. I forgot to mention that we are passing the hash function in the dependency injection. The hash function is the function that we will use to compute the hash from the password in clear test. And then, of course, this could be a left or a right. And this we will face this problem a few times, that we have a monad. In this case, this function is using the either monad, and of course, we don't want to be linked, we don't want to be attached. It is to a monad at this moment. So what we are doing here is we are using a built-in support in our programming language that can transform from one monad to the other. So what I'm saying here is, okay, you use the either monad, that's not a problem for me. I will transform the either monad into whatever monad that we are using at the high level to compose all the functions. Once that we have the ciphertext, then we are going to ask our vault for the password for this user. And then probably we can have a password or not. And because if you don't know the user, you don't have a password for this user in your vault. In the case that you already know the user, that is a user who has signed into your system, then you will have a password, otherwise not. And then we will just compute the access by means of this structure, which is one of the most useful structures for me. This is an exhaustive pattern machine. So here, there are only two options. There are only two options here. On one hand, you have a hash because this user was registered in your system, and in this case, the only thing that you need to do is to compare the hash that you have in your vault with the hash that you compute using the password in clear test in his hashed way. If this match, then you have a granted access. If not, you have forbidden access. And in the case that you don't have a password for this user in your vault, then you will just return a forbidden access. You create here in the map the access decision by using the username and the access. That's all. Cool. So why this matter? Well, the first thing is that by coding in this way, you will have a few things by free. You will have fearless refactor, because refactor in this code is pretty easy because you have the help of the compiler to every time that you make a change and every time that this change breaks something in your system, you will have a warning from your compiler. And imagine that someone new joined your team. Giving this person the opportunity to work in your code base, it will be the best way of onboarding this person. And this person will be productive in very few time. And you can do this safely because this person cannot break anything in your system, because the compiler is here to help you to avoid that you can break your system easily. Okay? And finally, you can start from here, and at some point, you can use your types to create your ubiquitous language. And then you can simply drop all these wikis or this Confluence or this kind of document that you share with your product manager. You can move all this information, you can move your ubiquitous languages into your type system. And you can create a domain-specific language that you can have this conversation in front of your code. Of course, that you need to put some effort in creating all these ubiquitous languages in such a way that you can share it with your product manager. Finally, take it with a pinch of salt. Monads and for comprehension enable function composition in Scala, but the language that you are using may have other great tools that serve exactly for the same purpose. So don't get the idea that you need monads or for comprehension to do functional programming. No, you may have coroutines or something else. In some cases, imagine that you're working with JavaScript, there is no introducing types, for instance, in JavaScript is completely useful. Okay, useless. Sorry, it's completely useless. So always have into account your context before introducing any of these patterns, before using any of these patterns. And finally, it doesn't have to be all or nothing. You can start. There are a few things, a few benefits that you can get from functional programming, and you can select and you can start just the aspect that matters the most to you. For instance, for me, if I have to start introducing functional programming in my team, I will start by introducing the no null. I will start by introducing the no exception. And I will start growing from this. As a summary, we introduce 5 functional programming patterns, the new types, where you create a new type every time that you need to define a value that have only one field, like the password. We also have a talk about making illegal state unrepresentable. We also describe how this can be done by using smart constructors. Then we also have introduced the phantom type parameters to create different types for the cases in which you have values with the same information but different formats. And finally, we also describe the evidence pattern. Of course, this is not those ideas are not mine. I inspired in this Haskell book, and also in the Alexis King blog, and also in a talk by Ronald Bjarnason, which I really believe 2 years after we started introducing this idea in my team. Now I have the feeling, no, it's not the feeling, I'm pretty sure that this was the right decision. Okay, so that's all. I don't know if we have time for queries, for taking queries. Okay, so thank you very much for your time and enjoy the conference.